Around 3,000 employees are needed to build one Lockheed Hercules aircraft. Today we take a look inside the American Lockheed Martin factory, located in Marietta, Georgia. This is the factory where the Lockheed Martin C-130J Super Hercules is assembled. It is a 4-engine turboprop military transport aircraft. As you may notice, employees in American factories usually have no mandatory dress code. So they go to work in whatever clothes they want. Hydraulic, electrical and other essential systems are installed and tested throughout the empty shell of the aircraft. The C-130J is the newest version of the C-130 Hercules and the only model currently in production. In the main assembly hall, employees assemble the individual elements of the aircraft. These parts are usually transported to this main hall from smaller sub-factories. This factory is officially called United States Air Force Plant 6 and has been in operation since 1942. The first steps in the production of this turboprop aircraft lead to the milling and manufacturing of the smallest parts. High-performance CNC milling machines are used for the precision manufacture of intricate aircraft control parts. The C-130J is a comprehensive update of the Lockheed C-130 Hercules, with new engines, flight deck, and other systems. A civilian variant of the Hercules aircraft is also being assembled here. It is called the Lockheed L-100 Hercules. The latest version is called LM-100J. A total of 115 of these aircraft are in service worldwide. These aircraft are powered by Rolls-Royce AE2100 engines. These are turboprop powerful engines. As you can see, the assembly starts with the preparation of the wing, then the engine is attached with a crane and the propeller is installed last. This engine has a power of 3,500 kilowatts. The engine uses 6-bladed, all-composite blade. The complete assembly of all 4 engines, including the blades, takes approximately 1 to 2 days and involves around 20 employees. All the necessary parts are of course supplied by other employees from this factory. Output quality control is the most thorough that exists in the aviation industry. Many times the entire aircraft is inspected during the manufacturing process. The wings for this aircraft are the only major components that are also manufactured at Lockheed Martin's Marietta plant. On this assembly line, multiple Lockheed Martin Hercules can be worked on simultaneously at each assembly point on the line. Here it assembles parts that come from other Lockheed Martin plants in Meridian, Mississippi and West Virginia. The almost finished aircraft is now taken out of the factory using small trolleys called towing cars. Hercules aircraft is then transported within the factory complex to a special hall where the entire aircraft is painted. You are now looking at a civilian version which is called LM-100J. But now I'm going to show you the whole process of painting the military version of the Lockheed Martin Super Hercules that will be delivered to the UK. All parts of the aircraft that need to be protected from paint are insulated with plastic wrap. This process takes many hours. Now a protective top layer of the paint is applied to the aircraft. The Lockheed Martin C-130J Super Hercules is one of the most purchased military transport aircraft in the world. This is a Hercules for the Royal Air Force painted in the colors of the 50th anniversary in service for the RAF. These employees have a difficult job in that usually each aircraft goes to a different customer and the whole fuselage needs to be painted in a different way. Of course, all of this is preceded by planning on the computer and creating a design that must be approved by the future owner. This Royal Air Force C-130J Super Hercules received a special paint livery to celebrate the 50th anniversary of the delivery of the RAF's first C-130 Hercules. Take a look at how this design was applied during a couple of days. The aircraft will now be taken out of the factory again and will undergo test flights and trials, culminating in a competency certification. Each aircraft is flight tested and certified by a verified quality control organization before delivery to the customer. Test pilots first test the software and controls on the flight simulator. This profession is very well paid and pilots can only apply for this position after many decades of piloting when they have the appropriate experience. Now an experienced crew will conduct a test flight where they will evaluate all the data and capabilities of the aircraft in flight. As you can see, it is not an easy job. With the L-100J Hercules, Lockheed Martin has enabled civil airlines to own one of the world's best transport aircraft. In an aerial delivery role, the Lockheed Martin L-100J can airdrop loads of up to 48,000 pounds, which is 21,772 kilograms. Or use its high flotation landing gear to land and deliver cargo on rough dirt strips. Capable of using unprepared runways for takeoffs and landings, the C-130 was originally designed as a troop, medevac, and cargo transport aircraft. The versatile airframe has found uses in other roles, including as a gunship, for airborne assault, search and rescue, scientific research support, weather reconnaissance, aerial refueling, maritime patrol, and aerial firefighting. It is now the main tactical airlifter for many military forces worldwide. Through select design changes, the L-100J performs as a civil multipurpose air freighter capable of rapid and efficient transport of cargo. The L-100J is an efficient and ideal airlift solution when delivering bulk and oversized cargo, particularly to austere locations worldwide. The maximum range is around 4,500 kilometers. The maximum speed is around 660 km per hour, which is 355 miles per hour. This Airbus Atlas A400M is a military transport aircraft that covers the size gap between the size of the C-130 Super Hercules and the C-17 Globemaster. This plane is produced in various European factories, with each contributing a significant part of the Atlas. This is a tactical airlifter with strategic potential. All of these parts of the Airbus Atlas being put together is referred to as the general assembly of the aircraft. The ramp door of the aircraft is built from Transall aluminum and tested for a perfect fit. It will be open for decades to come and must work flawlessly. The A400M has a removable refueling probe mounted above the cockpit, allowing it to receive fuel from drogue-equipped tankers. Current strategic aircraft are good outsize load airlifters, but are costly and have limited tactical capability as they cannot operate from soft fields. It can carry heavier loads than the C-130 and can use rough landing strips. In addition to its transport capabilities, the A400M can perform aerial refueling and medical evacuation when fitted with appropriate equipment. The A400M combines the capability to carry strategic loads with the ability to deliver even into tactical locations with small and unprepared airstrips and can act as a frontline tanker. One aircraft that can do the work of three, the A400M. Inside the factory, cranes are always used to transport heavy parts. For example, fuselage construction of the Airbus A400M occurs in Bremen, Germany, and partly in Spain. Airframe is constructed from aluminium alloy, as are the rudder structural frame. Titanium alloy is used around windscreen, wing fuselage joints, and landing gear components as well as tailplane central joint. Over a third of structure is made from composite materials including tailplane outer boxes, wing box, trailing edge shroud and most of the rudder. Wing skins, stringers, spars and moving surfaces are made from carbon fiber composites, landing gear doors and fairings from glass fiber or carbon fiber. Two pilots and additional crew member in a full glass cockpit face two mission computers, two wide-angled head-up displays and 8 color head-down displays with side stick controllers each, centrally positioned throttle control and fly-by-wire control systems with side stick controllers. The A400M Maintenance Center is being built right next to the air base of Air Transport Squadron 62 in Wunstorf in Germany. Airbus will create 300 new jobs at the A400M Maintenance Center in Wunstorf, searching mainly for aeronautical engineering personnel. Thanks to its combined strategic and tactical capabilities, the A400M has proven better range, speed, altitude, payload, and tactical performance than previous generation tactical airlifters, enabling the delivery of game-changing capabilities to the point of need, such as next to a natural disaster or a theater of operations where strategic airlifters cannot operate. The center wing box of the A400M is the primary load-carrying structure on the aircraft. In this part of the factory, surface protection is applied to the exterior of the Airbus Atlas, and this is also the sealing process. Precision is required for a quality finish and effective sealing. The surface protection seals the interior of the aircraft from the outside environment, thus preventing corrosion. The whole process of painting an aircraft takes several days, and the price always depends on the customer's requirements. Delivery heavy payloads is up to 37 tons. Airbus Military Division employs around 3,000 people. This aircraft is used by the militaries of Chile, the Czech Republic, Hungary, Indonesia, Kazakhstan, Malaysia, South Africa, and also South Korea. The aircraft has also demonstrated its worth in supporting humanitarian and disaster relief operations as well as VIP transport.
The Airbus A400M is a multi-role military transport aircraft that is known for its impressive performance, versatility, and advanced capabilities. The production process of the Airbus A400M involves a complex and highly coordinated effort that spans across various stages, from design and engineering to manufacturing and final assembly. The production of Airbus A400M begins with extensive design and engineering work. A team of skilled engineers and designers work together to develop the aircraft specifications, performance requirements, and systems integration. This involves computer-aided design and computer-aided engineering processes, including 3D modeling, simulation, and testing, to ensure the aircraft's structural integrity, aerodynamics, and overall performance. Once the design is finalized, a manufacturing process begins. The Airbus A400M is a complex aircraft that requires the fabrication of numerous components and subassemblies, including the fuselage, wings, engines, landing gear, avionics, and other systems. These components are manufactured using advanced materials, such as composites and metals, in state-of-the-art production facilities. The production of the Airbus A400M also involves a complex global supply chain, with various suppliers and partners involved in the manufacturing process. Airbus works with a network of international suppliers who provide components and subassemblies for the aircraft. These suppliers are carefully selected and managed to ensure that they meet Airbus high-quality standards and delivery timelines. Once the components and subassemblies are manufactured, they are transported to the final assembly line. The final assembly of the Airbus A400M takes place at Airbus' state-of-the-art facility in Seville, Spain. This facility is specifically dedicated to the production of the A400M and is equipped with advanced assembly tools and technologies. The final assembly process involves the integration of all the components and subassemblies to create the complete aircraft. Skilled technicians and engineers work together to install the engines, landing gear, avionics, and other systems, and perform rigorous quality checks and testing at each stage of the assembly process. Once the aircraft is fully assembled, it undergoes extensive testing and certification to ensure that it meets all the regulatory requirements and safety standards. This includes ground testing, flight testing, and other performance evaluations to validate the aircraft's performance, reliability, and safety features. The A400M is subject to stringent testing procedures, including structural tests, endurance tests, and environmental tests, to ensure its durability and performance in a variety of operating conditions. After the aircraft successfully completes testing and certification, it is delivered to the customer. Airbus works closely with its customers, which include various air forces around the world, to ensure a smooth delivery process. The customer acceptance process involves thorough inspections and verification of the aircraft's conformity to the customer's specifications and requirements. So, the production of the Airbus A400M is a complex and highly coordinated process that involves design, engineering, manufacturing, supply chain management, final assembly, testing, and certification. It requires the expertise of skilled engineers, technicians, and workers, as well as advanced facilities and technologies, to ensure the highest quality and performance of this advanced military transport aircraft. The Beluga is a specialized transport aircraft operated by Airbus, designed to carry oversized and heavy cargo, including aircraft components such as wings, fuselage sections, and other large parts. The Beluga is used to transport these parts from various Airbus production sites to the final assembly lines, including for the Airbus A400M Atlas. The Beluga features a distinctive bulbous fuselage, which allows it to accommodate large and bulky cargo. The loading process typically involves several steps. Prior to loading, the Airbus A400M parts are carefully prepared for transportation. This includes protecting them from potential damage during transit, such as covering them with protective coatings or packaging them in special crates or containers. The Beluga has a large cargo hold that can be accessed through a large, upward-opening cargo door located at the front of the aircraft. The cargo is loaded into the hold using specialized ground handling equipment, such as cranes or loaders. The cargo is secured using straps nets, or other methods to ensure it is stable and safe during transportation. Once the cargo is loaded and secured, the beluga transports the parts from the production site to the designated final assembly line, which could be in another country or even on another continent. The beluga is capable of flying long distances with heavy cargo, thanks to its high payload capacity and extended range. Upon arrival at the final assembly line, the cargo is carefully unloaded from the beluga using similar ground handling equipment. The parts are then transported to the appropriate assembly stations for integration into the final assembly process of the Airbus A400M. The beluga plays a critical role in Airbus global production and supply chain, enabling the transportation of large aircraft components efficiently and effectively. Its unique design and capabilities make it an essential asset in the production process of aircraft, such as the Airbus A400M Atlas, ensuring timely delivery of parts to the final assembly line for aircraft production. The Airbus A400M Atlas is manufactured at several Airbus facilities located in different countries. These facilities are part of Airbus' global production network, where various components and sub-assemblies of the A400M are manufactured and then transported to the final assembly line for integration. The main production sites for the Airbus A400M Atlas are Airbus Defence and Space facility in Seville, Spain. This is the final assembly line for the A400M, where the aircraft is fully assembled and undergoes testing and certification. The Seville facility is dedicated exclusively to the production of the A400M and is the main assembly site for the aircraft. Airbus Defence and Space facility in San Pablo, Spain. This facility is located adjacent to the final assembly line in Seville and is responsible for manufacturing the wings of the A400M. The wings are then transported to the final assembly line for installation. Airbus Defence and Space facility in Bremen, Germany. This facility manufactures the fuselage sections of the A400M, which are then transported to the final assembly line in Seville for final assembly. Airbus Defence and Space facility in Filton, United Kingdom. This facility manufactures the empennage section of the A400M, which includes the vertical and horizontal tailplanes, as well as the rear fuselage sections. These components are then transported to the final assembly line for integration. Airbus Defence and Space facility in Tablada, Spain. This facility manufactures the horizontal tailplanes for the A400M, which are then transported to the final assembly line for installation. Various other Airbus facilities and partner companies across Europe. There are numerous other Airbus facilities and partner companies across Europe that manufacture various components and systems for the A400M, including engines, landing gear, avionics, and other systems. These facilities work in close coordination with each other to ensure a smooth production process and timely delivery of the Airbus A400M Atlas to its customers, which include various air forces around the world. The painting process for Airbus planes, including the Airbus A400M Atlas, typically involves several stages, including preparation, priming, painting, and finishing. The process is carried out in a controlled environment to ensure a high-quality and durable finish on the aircraft's exterior. The first step in the painting process is the preparation of the aircraft surface. This involves thorough cleaning and removal of any dirt, debris, or old paint. The surface is then sanded and smoothed to create a clean and even surface for the paint to adhere to. Once the surface is prepared, a layer of primer is applied to the aircraft's exterior. The primer helps to improve paint adhesion, protect the surface from corrosion, and provide a smooth base for the top coat. The primer is usually applied using spray guns or other specialized painting equipment. After the primer is applied and allowed to dry, the actual painting process begins. The aircraft is typically painted in a paint booth or a controlled environment to minimize dust and other contaminants. The paint is typically applied using high-quality paint sprayers that evenly coat the surface of the aircraft with the desired paint color. Multiple coats of paint may be applied to achieve the desired thickness and color saturation. Once the paint is applied, the aircraft goes through a finishing process. This includes applying any decals, logos, or other markings as required. Additionally, the clear protective topcoat may be applied to further protect the paint and enhance its durability. Throughout the painting process, quality control measures are in place to ensure that the paint adheres properly, has the correct color, and meets the required specifications. Inspections are carried out at various stages, and any defects or imperfections are addressed and corrected as necessary. Drying and curing. After the painting is complete, the aircraft is allowed to dry and cure in a controlled environment. This allows the paint to fully harden and cure, ensuring a durable finish that can withstand the rigors of aircraft operations. The painting process for Airbus planes is carried out with strict adherence to aviation industry standards and regulations, and Airbus follows rigorous quality control procedures to ensure that the painted aircraft meet the highest standards of quality, durability, and appearance.